This is our last speaker of the day, and he's so good, and his talk is going to be so wonderful. There wasn't a single sponsor who could come up with the money to insert their video before his talk. Not one. Come see me next year, 20K, we'll make it happen. But until then, everybody give it up for Kelsey Hightower.
I was thinking about how to start this talk, right? We're talking about the secure software supply chain. The only problem is I'm not a security expert. So now what? Should you trust anything I say today? There was another problem. When I was preparing for this talk, I actually wasn't feeling that great. There's a lot happening in the world right now, outside of our laptops, outside of the sprint planning that we have to do. And I actually didn't finish my demo. And I actually made a call. I could just stay in the US and pretend it never happened. Or I can get on the flight and stop pretending that the world is perfect. We get as far as we can get. Now, the secure software supply chain is an important topic, but what does it actually mean for developers? And so when we think about this software supply chain and why do we hear about it? It's 2022. Why is everyone making so much noise about it? Well, we have this company to thank. Solarwinds will represent this pivotal point in security. So imagine this. You do all the things you're supposed to do. You buy all the security software. You know how this works. You install 5,000 agents on the VM. It eats up all the memory and disk space. And someone comes around and says, it's secure. How many people believe them when they tell you that it's secure? I don't think anyone does. We only are making a best effort when it comes to the security thing. And honestly, I think most of us are almost making no effort when it comes to the security thing. Think about the average developer workflow. Think about it. You got something to do by Friday. Maybe it's something you've never done before. How do you go about it? You go online, you go to Stack Overflow, you copy and paste the first example that works, you bring in the dependencies, looks good to me, and off it goes to production. The auditor comes around and says, looks good to me. And you're like, what the hell did you look at? I don't believe you. The SolarWinds situation was very interesting. These are security companies that their whole business is to help you be secure. And if you're unaware of the SolarWinds story, this is very sophisticated. This is what happens when someone wants to target you and all of your customers. It almost feels like there's nothing you can do to prevent this. This is one of these attacks where the hackers were super patient. They were more patient than your security team. They were willing to just lay low for almost a year before actually using their vulnerability. How did the vulnerability get in place? One big part of the supply chain that's a problem is the bill system. How many people here believe they have a very secure bill system? One person raised their hand. This person's boss is like, you're lying. We literally downloaded it from the internet. We have no idea how secure it is. But you use it. And how do we find out about most security vulnerabilities? Someone else tells us. We don't typically find them ourselves. So in the case of SolarWinds, another entity told them that their software was vulnerable and that it's been used to steal and gather data from their guests, 18,000 of their customers, without anyone knowing, including all the security professionals, including the government entities, who this was their sole job. So if you're like me, I'm thinking, what chance do I have? It got so bad that they even had to testify in front of Congress. How the hell did this happen? Aren't you supposed to be the experts? if you can't prevent this, what do we do? And they gave their testimony, and all I could think of as a developer, as someone who was responsible for writing code, what is my role in all of this? Do I just wait for the operations team to provide a secure end-to-end pipeline? There's been a few talks today that actually showed you how to put those pieces together, but honestly, it's a bit too abstract for most people to take that first step. So what does that first step actually look like? I don't have any more slides, and so what I'm going to do is attempt to talk through how I went about this. If you're like me, you have a lot of browser tabs open, and you hear all of these things that come across social media, maybe even at a conference talk. There's this thing called SigStore. He's like, oh, SigStore, let me go download it and see what that will do. And then there's more and more pieces that contribute to this end-to-end supply chain. And so for me, I just started building things and just gave it a test. What should I do at each of these steps? Not sure what that buzzing is, but it feels dangerous. So to me, the first step is to actually write code. And I get that this is incredibly small. And I'm hoping I can actually zoom out here. All right. And I wrote a bunch of code. And I decided to write a very simple web application. It's a user service. I'm using gRPC. And one big problem we have is we don't really know who wrote most of the code that we're using. Can anyone tell me exactly who at Google wrote this gRPC reflection package? Does anyone care? Turns out most of us don't actually care, right? What do? I'm going to show you the process. We say we need a, let's say we take GitHub, I need a JSON or a YAML library for Go, okay? And then what do? You say, oh, this one came up first, this must be legit. It came up first. Look at all the stars. That's 5,600 stars. My manager said we need one more than that, so you fixed the problem. There you go. Now the manager's happy. It passes the reputation check. And we literally import this, and off we go. The whole company is spending tons of money securing the entire network, securing the VMs, the containers, Kubernetes, the load balancer, and here you are going to GitHub and copying and pasting random URLs from people you have no idea who they are. Now, we all like to think that these security attacks are going to be done by like a James Bond-like character. They're going to show up and do some Mission Impossible thing. No, they're not. They're going to be a developer on GitHub, and they're just going to post a very popular package, and they will wait. Because you're going to download it automatically, even in your CI/CD system. You're like, is there a new version of the pack? Is there a new feature to the back door? Let me bring that in. Because we're not going to check. So the first thing we probably need to do as a developer, I said, you know what I need to do is probably start signing my Git commits. How many people sign their Git commits? That's 9 people out of 500. We got a problem. Most people don't know that you can actually sign your commits. So there you go. One thing you can do different is start signing your commits. What does it look like when you sign your commits, actually? So I have this little simple service. It's called a user service. And for the most part, I wasn't signing commits either. I was just pushing code. And for a lot of my commits, I got this kind of unverified thing. So the first thing I did is go to GitHub and said, anytime someone uses my email address in their Git commit messages, did you all know that you can use any email address you want when you do a commit message or when you commit something to your Git log? Right? You can literally have Elon Musk working at your company, contributing code to your code base, and it will look totally legit. But people can also do that for your email address. So step 1, leverage the tools that say, hey, unless they sign that commit with my GPG key, I would like this to show up, unverified. That's step 1. Right? The last thing you want is someone showing up to your door saying, hey, you committed this arbitrary code. We want to have a conversation. Step 2, start signing your commits. What does that actually look like? I'm going to show you my Git config. You see that one line at the bottom? GPG sign equals true. So generate a GPG key, export the public key, and throw it in a tool like GitHub, and add that one line, and you will start signing your commits. You got to do this, folks. This is the first step. This is an easy one, low-hanging fruit. So once you sign your commits, you're off to a good start. Next is, what is inside of your application? In the early days of the United States forming, there were no food labels on food. You would literally buy something, and you would guess what was in there. One of the US presidents, the presidents of the United States, died at a picnic from something he ate. Literally dead. And someone said, maybe we should put the ingredients on the food so people know what's in there. I know, innovative. And software is no different. What is inside of the software we're building? Now, I write code in Golang. There are lots of languages out there. You can pick one, but I think the Go programming language and the team has gone a long way to make this work. So we have a thing called Go modules. And what we attempt to do is for every import that you import into your application, we attempt to bring down the package that you depend on, describe your indirect dependencies, and also store the hashes to these things in a sum file. That way, if you're pinning yourself to a specific version, and that version were to change, you will get an error at build time saying this isn't the same thing that you think it is. And you should take notice. I'm one of those people that like to actually vendor our dependencies. If you don't know what vendoring is, it's this idea that you should probably copy all of the source code you depend on into a directory and check it in with your other source code. Now, there's some people here that's like, Kelsey, that's literally insane. Why would you check in all your dependencies when you can pull them from the nice, trustworthy safety of the internet? Anyone ever have a build process fail because the internet was down? Or GitHub was down? It doesn't look like a good idea anymore. It's like, damn, I wish we would have vendored those dependencies. The other value about vendoring those dependencies is you can run static analysis to check for bad things in your actual build environment without necessarily relying on upstream. This is also another form of denial of service. If I just simply remove my package from GitHub, then you have work to do. You may not be able to do your next build. So consider vendoring these things. The next thing here is once we vendor these things, there's a thing that we've been talking about a lot at this conference, which is the software bill of materials. Again, with my tabs open, I'm trying to figure out what are people doing about this issue? And one of them is producing a SBOM. So the easiest way to do this, how about this? We'll just do SBOMs. It's probably a big hit these days. And so now you have a lot of these companies that are actually producing software to help you build what we call software bill of materials. All right? There's plenty of sites that explain what this is, but the goal is we need to start putting those labels on our software so we actually know where things come from. If you want to understand how this works is, an SBOM is not going to prevent you from being hacked or a vulnerability. Think about when you buy a car. Let's say your car has a faulty airbag. How do you find out your car has a faulty airbag? You could crash your car. I don't know if that's the best idea. But one day, somewhere in the world, someone will probably have an accident and their airbag will fail to deploy. One thing the auto industry has is the ability to detect where that manufacturer's airbag is across all the cars, and they can do a recall. And they can prevent the next person from having a problem with their airbag. We need to do the same thing. So in order to do that, we need to be clear on what our packages are, and there's tools to do that. So I'm going to run one of them. So I found a really cool tool that will help me generate an SBOM. And we're going to do generate SBOM. And it's a package called Swift, or a command line tool called Swift. And what it does is I can give it my binary, and I'll talk about some other things that we can do here that I think is pretty cool. But I can basically give it my binary that I built, and it will generate a software bill of materials from that particular binary. So the first thing I'm going to do now is just build my binary, go build. And I just get this simple binary called user service. And what I'm going to do is have this tool read that file and generate an SBOM. All right? And so what we end up with is this thing. There's a ton of information in this thing. It's actually pretty overwhelming. But what it attempts to do is it goes into that binary, and the Go programming language is actually pretty cool. It actually knows how to, at compile time, include all of your dependencies in that resulting binary that can actually be pulled out by tools like this. It's hot. People are fanning in here like it's, like it's church. And you can see all of these dependencies I have. I have gRPC, I have my database, I have Spanner, but now we actually have enough metadata to go along with our binary that we can actually start to trace things back to where they come from. The other cool thing you can do is you can actually scan this SBOM for vulnerabilities. So the goal is you have your software, you're signing your commits, you've generated this software bill of materials, and then what you can do is after you deploy your software, you can continuously scan this bill of materials to see if you have any problems. I'm going to run that command now. And what it does is it will load that file and use its local vulnerability database that it continuously updates in the background to try to give you some insight on what's going on. Now, why is this important? In the security industry right now, there's this push to start shifting left some of the responsibility. We can't wait until the software is built and then scan it once it's deployed, or maybe scanning it right before it's deployed. As a developer, that's the focus of today, what is your responsibility in this equation? We want to start shifting some of these tools left. So you can imagine on save, when I'm compiling my software or I think I'm done for the day, I can run these tools in the background to give me some feedback about what's going on in terms of the software I'm choosing to construct. And so this gives us that first set of tools where we can start to identify what we have, attach those labels, and if someone else in the world were to report a vulnerability for something that we're using, now we have tools that would alert us to that. And remember, we should be putting these tools in multiple places, so not just on your laptop. This will go into your CI and CD build system. This should go into maybe your continuously monitoring system after things are deployed, and then you can start to have a remediation set of steps. But these are the minimal steps that I think we could do as a software development community that is serious about our craft to make sure that we at least know what we're putting inside of the software that we're all building. Now, there's a lot more to this equation. I've only talked about one part of this puzzle. There's other things we have to do. We have to sign this software. And there's a way of going about it. There's a whole bunch of tooling, and this is what the whole SIG store project is all about. Once you've put the whole application set together and you want to ship an artifact to someone else, there's a chance that you need to sign that software so I can verify if I trust you, the signer, or not. Right? Maybe I don't want software from you because you're known to have bad software or it just doesn't work, or you've been responsible for some vulnerabilities. And there's a bunch of command line tools that they have for doing this. And one of them is called cosign. And for the sake of time, what cosign typically produces is, this is a very cool thing that happened where we're all familiar with Docker, but what people have done is they've repurposed Docker registries to be able to store generic content. So not just container images, but those software bill of materials. We can attach them now side by side with the applications we're deploying. And then we can sign those artifacts. So the reason why this is important is that now other tools in the ecosystem can just come to your registry. I'm going to show you that. And when they go to your registry now, you're going to see a lot of these extra digests, and I'm going to zoom in a little bit here. But what you'll see is like your container image, so here's a tag, and that tag has a hash, and that hash will be used to generate a detached signature. So I'm going to take my key as a developer, or I'm the build system, and what I'm going to do is generate a signature that says, I built or I trust that thing. And the next thing we're going to do is we're going to take that SBOM and we're going to do the same thing. We're just going to take the SBOM and stick it in a container image, store it next to the other image in the registry, and then we're going to sign that too. So at this point, all the tools now have everything they need to do this continuous feedback loop for us. So as a developer, not only are we shipping our application, we're shipping it with that label so we know what's going on. Now, there's a lot more to talk about here, so we're going to shift to a slightly different format to have a discussion, because in my attempts to build an end-to-end demo for this, there are just way too many moving pieces. And so I'm happy to invite Adrian to the stage. Adrian works at ChainGuard, but Adrian is the first person, one of the first people I met when I arrived to Europe for the first time, and he's going to join me to talk a little bit more about secure supply chain. Welcome Adrian to the stage.
Oh, we have chairs, amazing. Yeah, thanks, Kelsey.
We're going to do a fireside chat style. You take that chair, I'll take this one. And we're going to roll into questions from the audience, but Adrian, maybe introduce yourself and let people know what you're working on.
Yeah, so, well, yeah, it goes back a long way. I think we met at, what was it, Software Circus, like 6 or 7 years ago?
Yeah, that was a conference in Amsterdam.
Yeah.
And I came to the podium, and confetti cannons went off.
That was Mark Coleman.
And I was like, this talk better be good.
But it was, because he did Tetris. He did like this amazing, Kelsey's famous for his live demos, but he did this amazing sort of Tetris demo describing how sort of Kubernetes works, right? Exactly. And around the same time, like my talks were nowhere near as good as Kelsey's, but I was doing talks on like Docker security. And that led me, I kept doing kind of similar things. About a few years ago at KubeCon 2018, I gave a talk on establishing image provenance and security in Kubernetes. And that describes some of the problems, that basically some of the same stuff we're talking about here. And just after that, no, a few years after that, ChainGuard started by Dan Lawrence. So I reached out to Dan and said, hey, would you be interested if I joined you? And for some reason, he said yes. So I now work at ChainGuard, and I'm helping them sort of solve and address some of these issues with supply chain security. If you don't mind, can I make a short announcement?
Yeah.
Yeah, so today we actually announced at ChainGuard we got 50 million in Series A funding led by Sequoia. And also we've announced our second product, which I'm involved in, which is basically secure base images. So trying to create base images that don't have all of the vulnerabilities that you see with Gripe.
So that's good news. That means the startup has money to pay you, actually.
Yeah, that's always helpful.
All right.
Cool. So before we came on stage, you asked me to hear it from a developer perspective. I've decided to ignore that advice to begin with. We will get straight back there, though. So you probably hate me for this, but imagine you were a CISO. What's the first thing you would do at a company? Like the first thing you'd look at, and what's the thing you're most scared about?
Yeah, so if I was if I was the security lead at a company, think about that meeting with the executive team, and they ask you a question, are we secure? And the best thing you can do is probably lie and say, yeah, we bought all the things and they're installed. What you don't know is how your developers think about this every day. What you don't know is, are the vendors that you trust, are they on top of their game? And so my focus would be, how good are we at our practice of incident response? When's the last time we did it? And how many people know how to actually do it? That would be the thing that kept me up most at night. And I would try to my best to, number one, document and learn that answer. And depending on what my state is, I would try to go do something about it.
Excellent. Actually, it's a bit of a trick question, because at ChainGuard, we did actually reach out to, they have contacts. They reached out to a couple of CISOs and asked exactly that question. And they both answered with exactly the same thing. I'm scared of going to jail, and I'm scared of being dragged in front of Congress. Which I thought, yeah, fair enough.
Jail is a pretty powerful motivator, right? No one really wants to go to jail for writing software, let alone because you trusted someone else with your vulnerabilities.
Okay. Let's take it back, and I think you kind of touched on this in your talk. If we look at it from a developer perspective, I think it made it worse. Is that better? Okay. If you look at it from a developer perspective, what's the sort of first thing you would look at tomorrow to try and improve some of these things? Or like a simple sort of low-hanging fruit that you could perhaps put into place?
I'm going to grab my towel out of my bag because I feel like I'm about to lose all of my water. Someone, if you're sitting next to my backpack right there, could you bring that to me, please?
No, I think it's that
right
one.
There,
yes,
yeah, that
you got
one.
it.
Yeah, don't steal anyone's backpack. Is there a towel there? Yeah, I want the towel. Yeah, let me see the, no, not the
towel,
backpack, the
towel.
towel. Yeah, you can't wipe your face with the backpack.
You can try.
Thank you. He's a brave soul. He doesn't even know where this towel has been.
So yeah, so back to the developer question. What would you do as just a normal developer at a company, and you were worried about supply chain security? What would you look at as a sort of low-hanging fruit that you could perhaps fix tomorrow?
I would actually get with my actual dev team and say, how many people are signing your commits? Like legitly. And if the answer is not very many people, then I know I actually have a problem because I don't think everyone is on the team aware of their responsibility in the supply chain. Step one, we have to have identity on who's doing what so we can trust. Why is this actually important? If someone were to compromise our build system, remember, GitHub accounts get compromised a lot. And if you're not actually signing your commits, anyone can just inject new code and no one will actually know or be paying attention. Think about the dev process. You pull the branch down, there's changes you don't have, rebase and keep moving. That's what people are doing in reality. So I'm going to need my team, step one, to understand their number one role in this process is to identify themselves and sign their commits and take ownership. Second, what are the dependencies? Can we actually rebuild the software? I don't know if you all remember the JavaScript incident where there was like one package that just got taken off and everyone's on Twitter at the same time, oh, what the hell is going on with NPM? It's like, why are you pulling in this library that does such a simple thing? So I think we should have a conversation as a team. What are our dependencies and why? And can we actually reproduce the software? The one thing that when I was reading and studying the Solarwinds attack, they were in Congress and they asked them, how could this happen? And someone said, is it true that there was a password that was locking down one of the systems where the password was Solarwinds 123? And they said yes. And we checked it into the source code. And we're not sure what it had access to or how big that blast radius was, but it did happen. That's the problem. And so to solve this build chain problem, and this is the extreme, I've never heard of any other company doing it this way. They are now, from their own testimony, using multiple build systems by 3 different groups, isolated from each other, and comparing the results. That way they can try to detect, has any of their build systems been compromised? This is an extreme view. Can you trust your compiler? Can you trust Jenkins? Can you trust all the things that go into building software? It isn't just your source code and the dependencies. So now they have this blueprint. Now they have a human element that is actually better than most of these tools that we're trusting to do this, to say, hey, on important releases of this software, we need to compare nodes. And hopefully, they'll be able to catch things like this before they become widespread.
Yeah, it's scary, isn't it, how far they have to go to actually say, with any sort of level of confidence, I think we're secure here. So I think you've seen SALSA, like I can't remember what it stands for, but you've seen the SALSA standard and the 4 levels that define it on build security, right? I've also found this repository on your GitHub, and I believe it's called No Code.
It's called No Code.
Yeah. Where do you think that lies in SALSA?
Can I show y'all No Code really quickly? I'm not sure if they can go back here. Kelsey Hightower.
So I put him on the spot here. For those of you that aren't aware, he's got it, great.
There you go. All right, we're going to do like an impromptu thing about no code. I'm in an airport one day, super bored, and after talking to a bunch of developers about them recreating the wheel for the billionth time, I'm like, why do people want to write so much code? Code is a liability. You got to damn near maintain it. It's all these things that go into it. It's not for free. And so I was sitting there, and I was going to do this tweet about, 52,000 stars. That's like a milestone. Never mind. So this thing called no code, and it reads, the best way to write secure and reliable applications, write nothing, deploy anywhere. And I like writing documentation for my code, including my application frameworks like this. And no code, if we just step through it one by one, no code is the best way to write in secure applications, and I have this really cool and convenient getting started guide. So in this guide, you start by writing nothing, just like this, right? It's blank on purpose because that's the syntax, right? Very simple. Most people know how to do it. But that's just an example. That's more like the hello world. But imagine you can do anything you want. You can add new features. So this is how you add new features. And it's very similar to like the hello world example, but a little bit more advanced. The next thing is the possibilities are endless, but now we have to build our application. So now that you've done nothing, it's time to build your application. And these are the build steps. I was very conscious about the number of steps required to do this, so I've gotten it down to the bare minimum. And then you should get this following output if you actually do it. You can deploy this anywhere you want. It works fine. Super simple. You can scale it. I know, right? And I had to put a contribution guide because I don't think people got the joke. People were literally trying to contribute. And if you look at this repo, and I actually had an email from some engineering manager say, hey, Kelsey, my whole team is distracted right now on this damn no-code repo. Can you take it down? My answer was no, but there's like 3,700 issues. Look at this. No code is still running and doing its job even after I stopped it. It's amazing. And, oh, a thumbs down, are you crazy? And there is one issue, and I can't find it, but the first issue someone opened, and it was a bug in GitHub. They opened the issue with no title, no body, no nothing, and it was valid. And the GitHub team was like, Kelsey, we fixed the bug, but we're going to leave the issue just for your repository. So if you have a long flight back to wherever you came from, walk through this, and I promise you, you're going to know why no code is super important. But the moral of the story is, we need to be explicit. Sometimes the best software is the software you don't actually write. And we need to have that mindset when we're thinking about the software we actually build. Great question. Wait a minute, did I see M1 support? Oh my goodness. I'm on it.
Thank you very much. That was exactly where, that wasn't prepared, so that was exactly where I was hoping you would go. So well done. Yeah, how are we doing for time? I'm wondering when we should
have
switch.
25 minutes, and there will be time for audience questions, so queue them up, and we'll take those as well.
Okay.
And we can jump to those whenever you're ready.
Yeah, I was going to ask something about the build systems and how, how would you, we've talked about at Solarwinds, how they've had to move to having 3 separate build systems. Now that's just not doable for your average company. I feel like a manager now. I should be asking you to take this repository down. Yeah.
So look, to your question, what do you do about this? Now we understand that this attack vector is very serious. I'm glad the thing we did was share our stories. Watching these security professionals testify in front of Congress about how bad or how prone we are to this situation, that was an important first step. When you go back to your job, when you go back to that project that you're working on, you need to actually take a look at your build system and ask a few questions. Where did this thing come from, and why do I believe it's secure? Depending on how important your software is, depending on who relies on that software, they're assuming that you've gotten this part under control. So imagine if you're shipping your software to a hospital. They're assuming you've done your part. And I don't think I didn't know is going to be a valid excuse going forward. There are some legislations that are trying to craft what does it mean to be a professional software developer? What type of things should be in place before we're willing to accept software? And I think now when it comes to these build systems, we're seeing these build systems become part of the supply chain that now will attest that they built something for you on behalf of you. So maybe we'll start seeing these trusted build services. What does it mean to be a trusted build service? What controls do you have in place that's going to provide these type of guarantees so that we as developers, when we're building code, we want to be sure that the binary that comes out hasn't been tampered with, and if it has, we want to know what happened about it. So I think at the build system level, we're going to have to probably do a bit of syscall profiling. What data is going out? There was a talk earlier today by Eric Brewer, and he talked about it, and he described a situation with a code coverage tool. And that code coverage tool was just taking your environment variables and sending them to a third-party site. And a lot of people are injecting credentials via environment variables And it took 2 months before anyone figured out that this was actually happening. Right there in your build system, your code coverage tool was a culprit. So we're going to have way more checks and balances about how this stuff is being built.
Yeah, I agree. And that kind of brings me to the point about the threats. So SolarWinds, that was possibly like a nation state or whatever, but that's a very sophisticated attacker. But does the average company need to be worried at that level, or should they be focusing on a much lower level?
Yeah, I mean, I think what this proves is that once you're a target, then, I don't know, good luck. I do think, though, as a smaller company, I think one of the biggest attack vectors is our software dependencies. Yeah. Literally, we're just pulling in random stuff from the internet. I know this sounds crazy. Maybe you feel like nothing's been exploited so far and it's fine. It isn't fine. This is actually a really bad practice, by the way. We have to do a slightly better job of understanding what this is and when we bring it in, because you're going to eventually circumvent the rest of your organization's security practices if we don't do our part at that level. So I think no matter what size company you are, if you're dealing with software, you should be doing this. But I think another part of Sigstore is that the people that are delivering you software, we want them to attest and sign for that software so we can keep track as a community and notify each other when there's something that goes off the rail. So if you're a smaller company, you don't have such a big security team, you probably do want to sign up for these notifications so that way you can figure out when you need to do something. Yeah.
Okay, I think I'll give a last question, and then we can move to the audience. But we all depend on open source libraries and software, and open source is fantastic. But there does seem to be a bit of a problem in that the projects themselves don't always have the most funding and the most resources to be able to tackle some of these problems. Do you have any sort of thoughts or ideas on that?
Who works on open source software here? We should give them a big round of applause. Come on, like seriously. I think Log4j was a good example. I think there was, a handful of people that maintain this library that's used by a large set of developers. A lot of times we're forced to maintain these software projects in our spare time. There is no funding because no one thinks it makes sense to actually pay money for software that they use to make money. It's like the logic is off. And so what happens when people lose interest in working for free? What happens when the volunteers run out and the software gets stale? Who's keeping an eye on the vulnerabilities? I think as an industry, what we're starting to see is new tools emerge. And remember, when I started almost 20 years ago, most of us were using Linux distros, and we got most of our software from the package manager. When Red Hat says there was a vulnerability, yum update, you brought in the new thing, and ideally it worked fine. But now a lot of software development is done by pulling packages directly from the GitHub repos in which they're stored. So who is doing these checks? Who is reporting these CVEs? Some of them aren't even using semantic versioning anymore. So how do we keep track of these things? So I think now as an open source community, seeing an open source project like Sigstore, it reminds me a lot of Let's Encrypt. Let's Encrypt was one of the first public good services that was based on an open source project. Most people that get SSL certificates from Let's Encrypt don't pay for them. And most people are not running their own CA server because that would be really hard to get all the browsers to trust your CA server. So now we all use this public good, and they are now securing probably the majority of the endpoints on the internet. When it comes to signing software and proving provenance and all of these things, I think there is going to be a new set of public infrastructure that will just make it easy as a software community and an open source community to do the right thing. There's new tools for releasing software. I write code in Go. There's a tool called Go Releaser that just tries to walk through all of these standard things, produce binaries and SBOMs in a standard way. So we raise the bar for what we expect from an open source project. There was a time when we got documentation and we were happy. But I think there's going to be a time where we're going to want those SBOMs and we're going to want the vulnerability checks. And I think the likes of GitHub and the rest of the community that are doing this in aggregate is going to go a long way.
Yeah, I'd also say I'd like to see companies perhaps supporting projects a little bit more. So lots of organizations use the software. They don't necessarily give back to the projects they're using.
Yeah, even if you don't contribute code, there's probably a way to contribute money.
Yeah.
Or even your feedback that you're actually using the project and any bugs that you find just to help the whole ecosystem.
Okay, can we move to public questions? I'm not sure how we do this.
Yeah, I think there's questions that show up. I think they have a Q&A deal. And there's the person that's going to help us with that. They're on the way to the stage. That's amazing. Hopefully you all have some questions. How many of you are like, life is now hopeless, I give up on software, I'm going to go live on a farm? That wasn't the intent. This is more of a call to action, that there are tools available, and we should be ready to use them.
Ladies and gentlemen, how about a big round of applause for these two gentlemen right here, first of all. Thank you, guys. Ready for some Q&A?
Yes, I am.
Yeah. I don't know who's going to take which question. You guys can fight over that if you'd like.
Yeah, and jump in where you see fit, Adrian.
Okay.
How about this top one here?
So I do have an interesting answer to this. It's about how do you secure your GPG key.
So I'm going to read the whole question out for everyone in the back. So how do you secure your GPG key? There are long and scary manuals how to protect your root key in the basement with dragons.
So I don't have a full answer right now, but I gave a talk earlier, and one of the things I brought up was keyless signing. And this is more at the minute for signing container images, but it means you don't need to have a key, like a private key, and keep it private and worry about people stealing it. You can instead use keyless signing, and what that does is you use an OIDC provider like GitHub, you log in with the OIDC provider, and a service called Fulcio will create a certificate for you, a short-lived certificate based on that OIDC provider. And basically, through that mechanism, you can avoid the need for having a private key and instead use an OIDC provider. The other thing I would say is you probably want to have like genuinely short-lived keys. The problem with GPG keys is they're long-lived. In general, things are a lot more secure if you can keep them short-lived. So if somebody else gets a hold of them, they're not going to be very useful for very long.
Yeah, and don't check them into GitHub would be my next one. A lot of people do that by mistake, actually. And also, like the thing about keys, I'm glad we're moving into this kind of passwordless world. Some people would consider having these private keys in the same vein. If we can get to these things where we're having shorter-lived credentials, we see this in the service mesh technologies as well. We want to get these things to be used for that purpose and then gone away, and then they can be revoked. And I think for most people, a lot of the tools that help you manage this on my Mac, I'm using a command line client that integrates with my local keychain. I'm putting a passphrase on it, and there's some tools that will help you also use something like a YubiKey that you can detach from your computer and take with you. And when that key is no longer valid, you need to revoke those things.
Awesome. Let's go to the next question. By adding all these vulnerability scanning tools, you just introduced a lot more dependencies you have to trust. How do you know these tools are to be trusted?
Yeah, I think for us as a community, like the tool I was using, Gripe, if you look at the documentation, it tells you the vulnerability databases it's pulling from, and it's configurable. And so what we want is, we might even get conflicting opinions, but we want as many of these vulnerability databases as we can to give their opinion about where we are in our source code. My guess is we'll see more and more kind of public good services that will have even more aggregation, and the number of security researchers that will be collaborating to make sure that we have these vulnerability databases up to date. I think that's going to just continue to get better over time. But at the end of the day, I think these are more feedback mechanisms, in my opinion. So as a developer, having something local on your laptop, remember, years ago, it wasn't easy to do this locally. It was one of these things you have to push to some central system. People were paying per the scan. Now we got these things that can just run on our laptops and give us a feedback loop locally. But then I think you have to run these checks again when you're doing that pull request, when you build the application, and then continuously moving forward. So I think what we have to do is maybe have multiple sources, trust but verify, and then we got to be consistently comparing notes. But I think there's no excuse not to at least see what you get and see where you are.
Yeah. I would say trust but verify is exactly right. Somebody asked in my talk, I ran the Kyverno admission controller, and they asked, well, how can I trust Kyverno? How do I know that wasn't a malicious version? And they're absolutely right. But you get back to like reflections on trust and trust. There's a very famous paper that I'm sure some of you have read. And do you trust your compiler? Do you trust the hardware it runs on? It's just about levels of paranoia, I guess.
And I think the big focus of what I was talking about today around this identity. If I decide to trust you, I need to know who you are And when you violate that trust, I need to be able to communicate to everyone that they should stop trusting this particular actor, whether it's by email address or binary or whatever key they use to sign software. We need that other component.
All right, next question. When will you push the M1 changes of no code?
Never. No, I'll probably do it later as soon as this talk is over because I also have an M1 Mac on the stage and I've been missing support. So it only takes me a few seconds and I'll do a new release.
Nice. They say that every chain is only as strong as its weakest link, and it always comes down to people. Example, how to protect against malicious insiders.
Well, again, I keep going back to this, identity, identity, identity. You cannot necessarily, without fail, offer a guarantee that no one will decide to be a bad actor. That's not something we can promise with these software tools. But what we can try to do, though, is require them to identify themselves, even if it's with a fake email, even if it's a key that you've never seen before. Because if it's a key you don't trust, then we know what to do with that. Hey, I don't recognize this key. I can't trust that. If you're something that I've been trusting for a while, and now you violate that trust, then we need to go look backwards and say, wait a minute, maybe you were no longer trustworthy, and we need to go look at some things, but going forward, you're on pause. We got to figure out what's going on with this. So I think the number one action we got to do is require a way to identify the code that we're writing and who's producing the software, and then we can do that. Because I think a lot of people have been trying to be perfect, make no mistakes, no one does anything bad. That's not sustainable, because what happens when they do?
Yeah, I'd probably add a couple of things as well. By default, people shouldn't have privileges to do everything. I mean, personally, I don't want privileges to push to production if I don't need them, for example. And also, you can do things like the verify part, trust and verify. So you can enforce like in a GitHub repository that somebody else has to sign off on commits, for example.
Yeah, and we see this a lot in open source communities where there will be someone that's on the release team.
Yeah.
And the release team is kind of responsible for making sure that things are actually ready to be released. And this gives you another check and balance. So maybe only the release team has the ability to sign software for that given cycle, and everyone else doesn't. So that's kind of a good situation of separating these roles and responsibilities.
A couple more. Java has jar verification since Maven. However, no one uses it. What do you think and why?
Yeah, I think this is the biggest problem. To me, there's a lot of UX problems, right? I remember when I was using Linux back in the day, SC Linux came out, right? And there was this promise that it's going to help us secure our systems, make sure that applications were only using the system calls, like opening files or using the network that we allowed them to. But it came so complex to use that most people, I used to look at the automation tools, the first thing you did was turn it off and then configure the rest of your system. Some of you are still turning it off, and you're sitting next to your security team, they're like, don't say it out loud, because it became too hard to use. I think what we're seeing now is people understanding that this stuff has got to get super easy. One thing we didn't show is some of the tools I was using, they know how to scan your actual artifact or your container or your libraries. So you just give it the path and say, hey, I got it from here. And so I think now that we have this kind of convenient way, and I think the development community or security community is understanding, you got to have user experience. You can't just say it works how it works, deal with it. Now there's a competition in this space. Like your company just raised a ton of cash. You're going to start to see a lot of people competing on the experience side, because once we get that right, it's going to be much easier just to do the right thing. And look, if you miss it there, guess what? There's going to be a whole slew of tools that will be able to catch it further down in the pipeline, although we should do it as early as we can.
Yeah.
How do we verify or trust dependencies when our dependencies bring in tons of others? Example, React or Angular.
Yeah, I mean, I was using gRPC, and when I did go get gRPC as a dependency, it felt like the whole internet came with it. It's like I don't need all of the internet, I just need this one part of it. And so I think that should be the first red flag. Why are there so many dependencies here? And I remember there were some open source projects I worked on where people asked that question, and the team was like, yeah, why do we have so many dependencies? And you start to look at what you're bringing in, and you start making some adjustments, like these are unnecessary, and you start pruning these dependencies. I would say the second step is just seeing them. Like, what are they? Which ones are direct? Which ones are indirect? And there's now a bunch of projects that are giving you the ability to actually inspect those dependencies. And again, static analysis is a thing. I don't know if we're going to catch everything in real time, but I do like the concept of vendoring. Not a lot of people believe in this idea of taking all of your dependencies and bundling next to your application, but I think there's a lot of power in that. You can actually inspect what those things are. My IDE will allow me to navigate those things. I can take a look. Also, I can diff. When I bring in a new dependency that brings in a new dependency, I can see this diff, that there are now 5 new things that are coming in, and that one library that says, I'm going to steal your credentials, well, maybe I don't allow that one in, and I can actually go resolve the issue. So I think, again, it just comes back to this consistent thing. Trust but verify. You have to look at this stuff because no one should be blindly trusting any of these things. So the answer isn't, or the question probably isn't, how do I trust? It's like, you can't, and you got to try your best to do at least due diligence on your part, and the ecosystem needs to catch up to help you in case you miss something.
Yeah, I fully agree as well. It's a problem that they're too big, and I would like to see perhaps moves to break it down so you don't have to pull on everything. I'm not sure.
And one thing I would say here is a lot of, I work in cloud, and in the cloud, we have a lot of serverless frameworks. And one of the touted benefits of serverless is a lot of these dependencies, so we have the shared responsibility, right? If I give you a VM, then the whole VM is your responsibility. The operating system, the kernel, and all the packages and software. That's your responsibility, and you bring your code. The higher we go up this abstraction chain, let's think about the world of serverless. You all will be familiar with things like Cloud Functions or Amazon's Lambda. That contract is very different. That contract says, well, maybe you give me a code snippet and a few libraries, but that runtime, that web framework, that's my responsibility, and I'll keep that updated underneath you, and we'll hold this contract that if there's something that needs to be updated, we'll fix it. Heroku was the first time I saw this model with build packs, right? I gave it my code, and they wrapped it around this build pack, and then that was the contract. Is that the safest thing to do in the world? I don't know, but you are delegating responsibility, but you need to be very explicit about who is in charge of what, and we got to hold each other accountable.
A couple more questions here, guys, then we're going to let you go.
Okay.
I promise? Yeah. I think some people in the audience have to use the bathroom as well, so just a couple more.
2 minutes.
How does commit signature behave when you have auto-merge features with pull requests?
I mean, I think it just works because it's on the git commit level. It's not at the merge point. So I don't see the issue here.
Yeah, so when you do git commit on your machine, the tooling will take your GPG key, sign things, and now it's in your local log. Remember, Git's a distributed version control system, so your log and your tree now has your signed commit. And when you push, then that's going to be part of the thing that is part of the actual pull request. One thing you might want to do, number one, if you're just doing auto merges, maybe, I don't know if I'm doing auto merges without a few checks. So one of those checks could be, are these commits signed? The answer is no. Maybe we say, hey, I tried to auto merge this and you're not doing your part. So I do love that as a mechanism to give feedback to people like, hey, we just ran gripe on this pull request and you have all the vulnerabilities known to man, and I think you should reduce those. So you give people this feedback. So it's a good place to put it.
Yep.
All right, and our last question. I'm surprised you suggested vendoring. Do you not trust proxy.golang.org? They say in FAQ they protect you from disappearing source.
So let's break this down. The proxy, so Google and the Go team and the ecosystem around Go said, listen, we have to do even better. This idea that everyone is pulling strike from GitHub and the module disappears. One thing to mitigate that is to have this proxy that says, when the Go tool says, I need a package, well, it can go to a proxy, and the proxy can say, well, I'm going to look for a real module, things that have tags, things that have all the proper things, and then I will be the thing that can cache your dependencies to give you this additional safeguard that if the upstream thing goes away, the proxy has a thing, and the proxy will be smart. If the developer tries to change the tag to point to a different place in the source tree and represent that as the exact same module, the proxy will flag it and say, this is definitely not the same thing that you think it is, and it gives us this early detection system. It's not that I don't trust that. I don't trust the network. You're not supposed to. There's no guarantee that you'll always be able to hit the proxy. And so I need the ability to rebuild my software. 5 years could go by, I need the ability to rebuild my software. Depending on your regulation level, you need to be able to rebuild the old software with the old dependencies, not the new dependencies. This is super hard to guarantee if you don't have all the software. So I'm still big on vendoring because I think when it comes to reproducibility, it's probably the best chance you have to ensure that you have less network dependencies or developer pulling their code in order to pull it off.
Yep. Final thought?
Final thoughts is we finally have the tools to do something about this. The tools are getting much easier to use. I think the steps in the contracts are super clear. Sign your commits, understand your dependencies, generate those SBOMs, let those SBOMs feed other systems that can tell you what licenses you're using. They can tell you if there's any vulnerabilities available, and treat it as part of your dev feedback loop, but understand that's not where it stops. That supply chain is super long. There are things that you have to do, but there's questions we're going to have to ask up and downstream, and the work is never done, but we have the tools to get started.
Before you guys go, we have a small gift for you. You know, it's for sharing because, you know, sharing is caring. Kelsey, I'm going to give this to you. It's up to you. What you do with it from here on out
Awesome, thank you.
is for you. Thank you, gentlemen. One last round of applause, please.